Why is probability in the universe fake? Because randomness is one of the hardest things to achieve in the universe. Whether it's flipping a coin or checking the weather forecast, none of them are truly random. Some people say the probabilities in quantum mechanics are real, but how could we ever prove that? Does true randomness really exist? Before we answer those questions, we need to answer a more basic one first. What exactly is probability? Probability is a mathematical measure of how likely something is to happen. Its value lies between 0 and 1, but the word likelihood itself has two fundamentally different meanings in philosophy. The first interpretation is the frequentist view. They believe probability is the frequency you get after repeating an experiment many times. For example, if you flip a coin 1,000 times and heads comes up about 500 times, then you say the probability is 50%. Or an insurance company may study a population of 1 million people and count how many get into car accidents each year. So, in this view, probability is an objective pattern that exists in the world, independent of human judgment. The second interpretation is the Bayesian view. They believe probability is not an objective law built into the world, but a measure of how strongly you believe something will happen. In other words, how much confidence you have in it. A frequentist cannot really answer the question, what is the probability that it will rain tomorrow? Because there is only one tomorrow. You can never repeat tomorrow 1,000 times. Count how often it rains. But a Bayesian can. Say you checked the forecast, looked at the satellite images, and felt today's humidity. You combine all that information and arrive at a judgment like, I'm 60% confident it will rain tomorrow. And if you step outside tonight and see dark clouds gathering overhead, that 60% may immediately update to 80%. For Bayesian, probability is not a fixed answer. It keeps changing as your information changes, always moving closer to the truth. Neither of these views is simply right or wrong, but both of them point to a deeper question. Does randomness itself come in different levels? The answer is yes. Randomness in the universe can be divided into 4 completely different levels. The first level is called Epistemic Randomness. You toss a coin. Half the time it lands one way, half the time the other. This is the lowest level of randomness. At its core, it is deterministic. Under Newtonian classical mechanics, the moment the coin is tossed, its initial speed, air resistance, gravity, and angle of rotation are all determined. The reason we don't know the result is simply that our measurement and computational abilities are not good enough. Stanford statistician Percy Diaconis built a coin-flipping machine that could precisely control the initial position, speed, and angle. It could make the coin land heads 100% of the time, or tails 100% of the time. His conclusion in the paper was basically this: coin tossing is not random in physics, and this idea extends to all randomness in the macroscopic world. If there were an all-knowing Laplace's demon, able to know the position and velocity of every particle in the universe at a single instant, then in its eyes, dice would have no probability at all. The result would be 100% determined. From the moment of the Big Bang, the ending of everything would already have been written, and we ourselves are made of atoms. Every thought you have, every decision you make, if you trace it back far enough, comes from hundreds of billions of neurons firing according to physical laws. To Laplace's demon, every thought and action you have right now would be predictable. Maybe you were just scrolling through YouTube when this video's title or thumbnail caught your eye. And the fact that you're still here, watching this exact part right now, may have been decided from the very beginning. So if you happen to scroll down, click the link in the description, and take a look at the latest version of EdrawMind, maybe that's just the next step the universe had planned for you. And honestly, if your goal is to turn messy information into something visual, structured, and easier to understand, that transition makes a lot of sense. With EdrawMind, you can turn videos into mind maps, organize scattered ideas, and quickly build a clearer structure from complex content. And the upcoming hand-drawn mode makes your mind maps more vivid, more beautiful, and more personal, with more shapes and more flexible layouts that help your ideas stand out. There's also Agent Mode, powered by the latest AI language models, to make idea building and thinking much easier. You can freely edit, expand, and reorganize your thoughts. So EdrawMind becomes a real tool for thinking. AI helps you start faster. EdrawMind helps you understand deeper. So first-level randomness is never a property of the world itself. It is only a limitation of the observer. As knowledge improves, this kind of randomness shrinks, and in principle could eventually go to 0. The second level is called Algorithmic Randomness, and it is also humanity's most perfect lie. Game gacha systems, computer shuffling, and random music playback all belong to this category. So how does a computer generate randomness? The answer is, it can't, not truly. A computer is an absolutely rational machine built out of zeros and ones. Every step it takes is strictly determined. Asking a machine to generate truly random numbers is like asking a calculator to invent a number out of thin air. It is logically contradictory. So clever programmers came up with a workaround. They give it a seed, usually something like the current time in milliseconds, then run that seed through a very complicated mathematical formula over and over again to produce a string of numbers that looks patternless. In theory, someone who knows the seed and the algorithm well enough can predict every number that comes next with 100% accuracy. Pseudo-random numbers even have cycles. If you stretch the sequence out far enough, the apparently random numbers will eventually start repeating. It's just that the cycle is usually something like 2 to the power of several hundred, far longer than the lifetime of the universe, so you never notice it. Every time you talk to AI, its answers may seem different every time, full of variation, but underneath, pseudo-random seeds are still at work. AI's creativity is also, at its core, the result of a mathematical formula. It is predicting the probability of the next token, but it is never truly random. The third level is called chaotic randomness, and it is the most hopeless kind of randomness in classical physics. Unlike the first two levels, chaotic randomness is still deterministic in principle. Every step follows strict causality. But it has one fatal feature: extreme sensitivity to initial conditions. In the 1960s, meteorologist Edward Lorenz was running a weather simulation and shortened one number from 0.506127 to 0.506. The difference was tiny, only about 1 part in 1,000, but after a few rounds of calculation, one prediction gave clear skies, and the other gave a thunderstorm. Even if you had an infinitely powerful supercomputer, as long as there is even the tiniest measurement error, the prediction will eventually collapse. This is a bit like the Sophon attack in the three-body problem, isn't it? And that makes it fundamentally different from the first two levels. In the first two levels, if you were smart enough and measured precisely enough, the randomness could be eliminated. But chaotic randomness tells you that even if you push everything to the limit, it still won't help. Third-level randomness comes from the complexity of the system. It is not just a knowledge problem, it is a complexity problem. The fourth level of randomness is absolute randomness. Radioactive decay, the path of a photon, and quantum tunneling all belong to this category. The first three levels all share one basic feature. They are all epistemic forms of randomness. The world itself is still deterministic. We are just not smart enough, so it only looks random to us. But the fourth level asks a more fundamental question. Even if you knew everything, would the outcome still be unknown? Quantum mechanics gives a disturbing answer: yes. Suppose you could go back in time, back to the exact same second, and do the exact same thing again. In the world of the first three levels, the result would always be the same, but the quantum world is different. You've probably heard of Schrödinger's cat. Before the box is open, the cat is both dead and alive. Even if you return to the exact same moment and open the box again, the result could be completely different. Classical intuition tells us there must be some hidden factor inside the box that already determines the cat's fate, something we simply haven't discovered yet. Physicists call that unknown factor a hidden variable. Einstein held on to that idea his entire life when he said God does not play dice. This is exactly what he meant. He believed that the randomness of the quantum world must be hiding a deeper deterministic cause underneath, one we simply haven't seen yet. But in 1964, physicist John Bell proved something mathematically. If hidden variables really existed, then we should be able to design an experiment to test for them. Imagine a pair of twins who separate and go to two different cities. They cannot see or hear each other. If their behavior is only based on some prearranged hidden plan, then the degree of correlation between them has a strict mathematical upper limit. But if they are truly entangled, like quantum particles, then their correlation can exceed that limit. That is Bell's famous inequality. And the actual experiments found that Bell's inequality was violated, which means hidden variables in that classical sense do not exist. Now imagine you are watching a specific carbon-14 atom in a laboratory, and you record that it decays today at exactly 10 a.m. Now suppose you step into a time machine, bring the exact same equipment, and travel back to 8 a.m. that same morning, while making sure not to disturb the atom at all. When time reaches 10 a.m. again, will that atom definitely decay? Not necessarily. At the moment the measurement happens, the universe produces an outcome as if by rolling dice. No cause, no deeper logic, just pure, absolute uncertainty. It is as if even the universe itself does not know what will happen next. Einstein was wrong. God really does play dice. True randomness in the quantum world may be one of the deepest secrets of the universe, and a property of reality itself. What's interesting is that some companies now place tiny radioactive materials next to detectors, and every time they detect an atomic decay event, they record it as a data point to generate true random numbers. A physical event at the scale of the universe can ultimately become your bank password. But there is an even bigger question here. We ourselves are made of atoms too, so which level does human free will belong to? The strange thing is, none of these levels can truly accommodate the idea of free will. It is difficult for us to judge whether our own choices are based on a kind of probabilistic behavior. Determinism gives you no freedom, chaos gives you no freedom, and even true randomness gives you no freedom. Because if something happens randomly, you did not choose it. It just happened randomly. That still is not freedom. So free will does not seem to belong to any of these levels because it is not asking where randomness comes from. It is asking something else. Do I really exist in the way I think I do? And that question may be even harder to answer than randomness itself. Based on all current experimental evidence, true randomness does exist. But one question always remains hanging in the air. Whether true randomness exists depends on how you interpret quantum mechanics. The true randomness we have been discussing so far belongs to the Copenhagen interpretation, where measurement causes the wave function to collapse, and the universe produces one random result. But if the many worlds interpretation is correct, then all outcomes happen at the same time, in different branches of the universe. In that framework, nothing is truly random. You just happen to live in one particular branch. In that view, true randomness does not exist at all. It is only an illusion of perspective. These two interpretations are mathematically equivalent, and no experiment has yet been able to distinguish between them. So, the more accurate answer is this. In every experiment we can currently perform, the evidence for true randomness is overwhelming. But at a deeper philosophical level, we still cannot rule out the possibility that true randomness is only an illusion. This is a question that neither physics nor philosophy can fully answer. Maybe it is one of the final secrets the universe has left for us.